In this broader course on data science, we have 5 sub-courses, one of which is statistics for data science. Now, statistics is an essential component in data science because data science will be dealing with a huge set of data, and to analyze this data, primarily the statistical methods are involved. So, to do that, we need to have a good understanding of statistical techniques. Now, whenever we talk about statistics, we talk about a population and a sample. Now, from the sample, we get the data, the observations as such, and the study related to this is referred to as descriptive statistics. So, descriptive statistics will be the first component in this course. After that, we'll be looking at probability theory, which is primarily concerned with the study of the population. It relates to the population and its characteristics. So, we'll be looking at both the population and the sample characteristics through descriptive statistics and probability theory. But then we need to make a synthesis of these two different studies, and that is done through statistical inference. So we'll be looking at how we relate the sample to the population and how do you relate the results that you get to the population characteristics. That will be done in the statistical inference classes, which will comprise of primarily hypothesis testing and a little bit of interval estimation and point estimation as well. We will also be looking at regression analysis, which actually tells us how certain variables are related among themselves and how one variable influences another variable. So it's a cause-effect relationship that we'll be studying. But to do all inferences and to do the regression analysis well also, we need to have a good plan layout of the way we collect the data. So this is done through sampling methods, and broadly sampling methods is done in two ways, either through what is referred to as design of experiments, which looks at experimental data, and for observational data we have sample survey methods. A little bit on these two methods will also be touched upon. Finally, what we'll be looking at is the Bayesian techniques. Bayesian techniques are somewhat different from the usual frequentist techniques that we study, but for many computational purposes, the Bayesian methods suits better than the frequentist methods. So we'll also have some discussions on the Bayesian methods. And finally, what we'll be doing is we'll be looking at a few case studies to illustrate the way statistical techniques can be used to handle data, particularly when you have large data or very complex type of data.